right, great. Thank you very much, David. So I want to begin with a couple thank yous. I've never been to University of Alabama before, so I'm delighted to be here. I'm still looking for Nick Saban, but I guess he's on TV all the time. Because if you don't lose, you're like on TV all the time. I'd like to thank the math department, the Department of Physics, and the library system here for inviting me. And one disclaimer, if you want to see a math talk, you're a little bit late. I gave one earlier today, so this is really not a math talk. I don't really know how to describe this lecture, except that I hope that one of the answers to the question, why does Ramanujan matter, I hope that at least one of the answers that I offer you speaks to you. And if more than one speaks to you, then even better. I'm a little bit embarrassed that my book is for sale here. It came out in 2016. I'll be happy to sign. But make no mistake, I'm just delighted to give this talk. And as you'll probably see, this is genuinely a very, very difficult talk to give. Not because the audience has many different interests. It's because this is kind of my life story. And if the story that I'm about to tell you, which is absolutely amazingly true, is of interest, then maybe the book is for you. So in any event, let me get started. Here's a picture of Ramanujan, one of the very few pictures that survive. And if you've never heard of him, I hope that this lecture goes a long way to convincing you that he should be a household name. I'd like you to think of him as someone that should be thought of as a Newton or an Einstein, someone whose ideas have transformed science, someone whose life is a role model for people who need hope. A lot of his life speaks to overcoming incredibly difficult odds. And for me, both of those roles were very important. I should be a bicycle shop mechanic. I shouldn't be vice president of the AMS. And I think I'll begin to tell you some of these stories. I first learned about Ramanujan on Saturday in 1984. I was in 10th grade. I'm the son of a mathematician. The apple doesn't tend to fall too far from the tree. And my dad came to the United States from Japan as a distinguished, promising number theorist. And when I was 16, the last thing I wanted to be was anything that my parents thought I should be, much less anything like my parents. You see, my parents were brought up at a time when they were told that their government was divine. They were told that the emperor was like God. You know the story, right? This was World War II. And try to imagine, which I didn't do until I was in my early 40s, try to imagine what your worldview would become as a teenager when you quickly learn that actually your emperor is not divine. Japanese people aren't really superior to the rest of the world because they were humiliated at the end of World War II. How does a country recover? Well, I'll tell you a little bit about that. For my parents, the years immediately after the end of World War II were very difficult. I mean, when your country loses in a world war, life is very difficult. There are shortages. Infrastructure is destroyed. And it was quite demoralizing. But for my father, it was important to him to try to escape the difficulties of life. I mean, they were literally starving. But my dad was also an academic. He wanted to be a mathematician. And he was also starving for knowledge. The universities had been destroyed. And one of the amazing things that the United States did at the end of World War II is they rebuilt Japan. And they rebuilt Japan in a very amazing way. And my father was discovered at one of the conferences that the United States held in the spirit of peace and reconciliation. And before he knew it, he was raising a family in the United States in a neighborhood surrounded by people that he was told to hate growing up. It was a very difficult time, right? Try to imagine being from a country that bombed Pearl Harbor. You're probably not going to be embraced with open arms. So it was a very difficult time for my parents. And from my parents' perspective, the only way that the 3 Ono kids could succeed is if we became star students, because nothing else about the United States spoke to them. I am the youngest of 3 kids, and so by the time I was growing up, all I understood was, why do I have to get perfect SAT scores? Why is it so important to get good grades? Why can't I, play Little League baseball like everyone else? And I didn't actually fully understand what my parents went through to try to raise a family in a country that they never understood. I love my parents. They're in their 90s now. They live in assisted care. But to this day, they are still afraid. They are still afraid, and they lock themselves in their room at night because they're afraid someone will break in. So what was their first few years of life in the United States like? Despite the fact that my father was a professor at the Institute for Advanced Study, and later a professor at Penn, and then finally a professor at Johns Hopkins, they had people shoot out the windows of their kitchen. They had people leaving burning bags of dog shit, if I'm allowed to be quite frank, on the porch when we were growing up. And as a kid, I didn't know any of that. And one of the things that I learned in writing this book and reflecting on my life was that, believe it or not, somehow this man, Ramanujan, has somehow magically interwoven our lives, as I will begin to tell you. So how did I first learn about Ramanujan? Everything I just said seemed to have nothing to do with Ramanujan. Well, I learned about Ramanujan when I was in 10th grade, not wanting to be anything like what my parents wanted me to be, until this letter arrived at the house. Let me read it to you. It's a very peculiar letter. It's one of my most valuable possessions, by the way. It's a letter that was written by S. Janaki Ammal, a woman who I'd never heard of before. And what this letter clearly is a form letter. Dear Sir, I understand from Mr. Richard Askey, Wisconsin, USA, that you've contributed for the sculpture in memory of my late husband, Mr. Srinivasa Ramanujan. I am happy over this event, and I thank you very much for your good gesture and wish you success in all of your endeavors. Signed, S. Janaki Ammal. And what's strange about that is I was the one that pulled the letter out of the mailbox. I gave it to my dad, and a few hours later, he comes to me basically in tears saying, I have to tell you the most amazing story. That's the day I first learned about Ramanujan. I didn't actually understand all of it. I didn't understand how this related to my dad, because my dad basically never cried. I never saw him tear up before this letter came. And we didn't actually come to terms until the late 90s, when he finally explained to me all that was going on that day. But what I did hear was, somehow there's a great man who died at the early age of 32, whose ideas came to him as visions from a goddess, who happened to be a 2-time college dropout. And what I heard was that my dad looked up to a 2-time college dropout as some sort of hero. And that was important to me, because up until that point, all I heard was good grades, test scores, get into the right schools. And if you're a student, you've heard it. So if you want some hope, do recognize that ultimately the time will come, hopefully it's already happening for you, where you will be evaluated for the quality of your work, your achievements, and the quality of your character. And I didn't learn that till I was 16 with this letter, because I thought that there was no way that would be part of my worldview. So what is the story of this letter? It turns out that Ramanujan died in 1920. This is a caricature of him. Quite a peculiar letterhead, if I must say. Look at the letterhead. Widow of late mathematical genius Srinivasa Ramanujan. It looks like it's fake. It looks like the stuff from like a cartoon, except it's totally real. So my dad told me about this amazing figure who he looked up to as a deity, who happened to die at an early age. And it turned out that by the early 1980s, almost 100 years after his birth, notice here he was born in 1887, the mathematicians of the world were preparing to celebrate the 100th anniversary of his birth. You must be something if a community is going to celebrate the 100th anniversary of your birth. And so, to celebrate the occasion, a reporter for The Hindu, think New York Times of India, thought maybe Ramanujan's widow, who he left behind in 1920, is still alive. And he found her living in the slums of Madras, now known as Chennai. And despite the fact that she had lived out the bulk of her life in poverty, she did point out that well, I loved my husband. He did great things. He was always doing his figuring. But if one thing bothers me, it was that when he died, the government of India promised to erect a statue in his honor. And what she did ask for was, where is the statue? And the mathematicians of the world got wind of this, and they all cobbled together their $25, $30 gifts. And they commissioned a statue that was given to her, and she wrote all the mathematicians of the world back. And I thought that was just a lovely story. And that's how I first learned about Ramanujan. I knew nothing about the mathematics at the time, but that was my first experience where actually this is a hero whose life actually meant something other than, like Hank Aaron could hit a lot of home runs. I didn't really know his story. But here was an example of someone who had unknowingly become someone I've been following my whole life. So in any event, if any of that sounds interesting, that's what this book is about. It turns out that I don't care how spiritual you are, I don't care if you believe in a Hindu god or not, but something about my relationship and my family's relationship to this man, both scientifically and emotionally, and in terms of the need for hope, has appeared in many, many different ways in my life, and is basically responsible for everything that has happened to me that has been good. Whether it was in college, the University of Chicago, later in graduate school, or the opportunity to work with Hollywood stars making a film, all of these things have made my life quite rich, and none of them would have happened without this letter and this amazing guy. So as I said, a few years ago, we made the film, The Man Who Knew Infinity, starring Dev Patel and Jeremy Irons. I cannot help but tell you crazy stories about what it's like to make a film. Dev he came to fame because he starred in the film Slumdog Millionaire. When we made this film, he had just broken up with his girlfriend, who was the lead actress from that film, Freida Pinto. He was all boy then. He's now grown up. Maybe you've seen him in the film Lion. And later this month, he's coming out. He will be in 2 films, one called The Wedding Guest, and another one called Hotel Mumbai, which will be a thrilling film about the unfortunate events of a few years ago in Mumbai and the terrorist attack. But in any event, here is proof that I actually worked on this film. I still talk to Dev every once in a while. He still sends me Christmas gifts. I can't believe that. And here is a picture of us on set talking about a theorem in complex analysis called Cauchy's residue theorem. What I like about this story is that this film even helped someone like Dev, who was a middling actor at the time, and he was very excited to work with the Jeremy Irons, who was the consummate actor. So before Jeremy arrived on set, I would talk to Dev like, how are we going to talk to Jeremy Irons? He's somehow going to elevate everything about this project. He had no idea that I was shocked that I was talking to someone like him, but it was actually very interesting on many different levels. One of the stories that I'll tell you about, many of the stories I'll tell you about, if I don't forget to, is to tell you about how important this film about this Indian man was to both Irons and Dev Patel. This was a small project. This is not Batman versus Superman. This was a small film, but it was a film that meant a lot to these actors. To give you proof, 1 week before the last presidential election, Jeremy Irons and I were invited by France Cordova. She's the current then and is the current director of the National Science Foundation. They invited us, with the blessing of President Obama, to the White House to participate in training events for the transition teams for the 2 leading presidential candidates at the time. You see, when you run for president, doesn't mean you know anything about being president. There's a whole operation in place, and so there's training. And shortly before Halloween, right before the election, the 2 leading presidential transition teams were invited to the White House, and one of those days was related to science and education. And as was planned, they wanted to present lectures and panels describing what the National Science Foundation does, what the NIH does, and I participated in that. And what we decided to do was, at the end of a very long day of talks and presentations, we would have a little party where we would show the film The Man Who Knew Infinity, because at the time there were a lot of very difficult issues that were in the air that NSF, NIH, and EPA wanted us to discuss. One of those issues was, of course, related to the importance of STEM education, so thank you for coming. It was very important. And another one is the importance of how to bring groups of people from different cultures, people with very different ideas together to do something great that would be otherwise impossible alone. And so they thought the film The Man Who Knew Infinity would be like perfect for this. And Jeremy, when he learned about this, said, I am coming. I'm going to come support this mission. And he did it for free. And I thought that was really awesome, right? And so here we are, right before the party. We're standing in front of the West Wing. And maybe some of you saw it. If not, it wasn't actually very exciting. I think it almost failed. That this is us giving a mathematics problem to the citizens of the United States. If you can read the board, it is the question, what is the smallest number that is a sum of two cubes in two different ways? And that's a question that you would have been answered had you seen the film. By the way, it's the number 1729. So a couple things about Ramanujan's life. And I'll show you some clips so that you can actually see in film, in action, some of the important features. Ramanujan was born a long time ago in a far, far away place. Think lush, tropical India. He was born in 1887 in southern India. He was born a Brahmin. Loosely think of that as the priestly caste. I think the vast majority of Indians who you might know in this country are probably Brahmin. Ramanujan, it won't come as a surprise, was gifted. He was a talented student. He won awards. And if you ever happen to travel to India, which I strongly recommend, it's a beautiful country. The colors are brilliant. The people are very, very warm. And it's probably very different from anything you've ever experienced if you've never been there before. Certainly the food is very, very different, and I've come to enjoy Indian food quite a bit. If you happen to travel to a town called Kumbakonam in the south of India, you couldn't actually visit the house in which he grew up. You can visit his high school, and the high school principal might actually show you the awards that he won over 100 years ago. Who keeps records like that? Ramanujan isn't someone that you could train. His ideas, as I said, came to him as visions from a goddess. So he started finding mathematical formulas on his own. And as we're told, he discovered much of trigonometry by himself using his own notation by the age of 13. If you're thinking, who in the world does that? Great question. Ramanujan did that. He rediscovered a lot of trigonometry on his own. And what I like about the story is when he discovered that trigonometry was not his invention, he really got upset. And he took his notebook, he threw it on the roof of his house, and, well, he returned to the mathematics maybe a few weeks later. But what does that show? That shows self-confidence, that shows ambition, and that shows drive, which is something that I think all young students need to remember is one of the critical features to being successful. Think of visiting a kindergarten class. Every kid can run fast. Everyone can sing. Everyone is good at everything. And somehow along the way, if you teach in a university, you discovered that idea of hope somehow vanishes. I don't know how we can rekindle that. So one of the things that I want you to take away from the story of Ramanujan was sheer self-confidence, the belief that he could make something better. And I like that. It's not about what you become. It's not about labels. It's not about what degrees you earn. It's really about what you achieve. And I learned that very, very early from my dad in learning about the story of Ramanujan. Ramanujan received as a gift, very strange, this book called Elementary Results in Pure Mathematics. When I was his age, if someone had given me this gift, I would have to truly wonder if that person was my friend. Who gives someone math books? I would have thought my mom, for sure, paid this kid to give me these books. But in any event, this is quite a remarkable book in the sense that this book should not have inspired anyone. It's a list of 6,000 or so theorems, just formulas. It's like a Wikipedia article, just listing 6,000 formulas, one after the other. But as the story goes, this book ignited Ramanujan's passion for mathematics, and he decided from that day on that he was going to assemble his own findings in his own notebooks, emulating the format that he saw in these books. I don't have time to go into what formulas inspired him, but let me just tell you about the very first page. The very first page begins with formulas you all know. A minus B equals A minus B. Check. So he's got 6,164 to go. The second one's a little bit better. A squared minus b squared equals a minus b times a plus b. Maybe only a little bit better, but I have 6,163 to go. But the next one, if you're a mathematician, or if you remember your high school algebra, is actually doing something. When he factorized a cubed minus b cubed is a minus b times a squared plus ab plus b squared. If in high school you saw that for the first time and thought, that actually represents a step, an idea, well, that might offer some insight into how Ramanujan viewed this book. Because immediately after that formula for a cubed minus b cubed, dot, 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 and then there's a sentence, and there's a general formula for all n, factorizing a to the n minus b to the n. And if you know what I'm talking about on that, about that step, observing differences of cubes, you will know then how to fill in the details. And I think most experts agree that Ramanujan viewed these dot, dot, dots, and there's a general pattern as his sort of like video game. I was playing Atari, he was filling in the dots. If you go to Chennai and visit the University of Madras Library, it should be against the law. Right? It'd be something like going to the National Archives and demanding to see the Declaration of Independence. But in any event, if you go to this library, you can ask to see Ramanujan's notebooks, and they will bring them out. Here is proof. Here are the 3 notebooks, and I got to tell you, I couldn't help myself but to really flip through and see all the pages, despite the fact these have been reproduced. To literally hold those books is kind of a magical experience. And if you ever do go, ask. Because there are almost no words. These are just pages upon pages of formulas. And your first thought might be, what are we talking about on these crazy formulas? What is it about these formulas that are so inspiring? And if you're thinking that, that's wonderful. Because let me tell you, it's 100 years later, and we're still trying to figure a lot of it out. I don't know many books that we study for over 100 years and continue to learn. There are a few books that come to mind. And in mathematics, these books, take my word for it, have led to several Fields medals. If you know about the distribution of multi-centered black holes, which has been in the news quite a bit lately, certainly in terms of mathematical models that are related to the discovery of gravitational waves, there are formulas in these notebooks that people put to use to write down those equations long before anyone was even talking about black holes. And that is crazy. If there isn't something spiritual about someone writing down formulas that would be needed to study black holes 100 years later, then I don't know what I could offer you that would be really quite striking. So Ramanujan became obsessed with mathematics, and he started to spend all of his time doing his mathematics, and as a result, he flunked out of college twice. I don't recommend that you flunk out of college. There are certainly benefits to being a good college student and getting good grades. But for Ramanujan, people who are artists, the kind of flights of fancy that you think of that are related to the creative pursuits in the world, Ramanujan was something like that. He spent a lot of his time in temples listening to drums, doing his mathematics. His mother actually sang in temples. And despite the fact he was a 2-time college dropout, he had friends. He had support. This is actually very important to me. Maybe I didn't do a very good job of explaining this before, but to be successful, nobody is successful by their own merits. Everyone needs help, whether it's a friend or a parent or a teacher, or maybe many people like that along the way. And Ramanujan certainly needed help. And the first people who supported him offered him work as a clerk, despite the fact that he was a 2-time college dropout. What I'd like to say here, and this is what I told my parents way back, was the amazing fact that despite his circumstances as a 2-time college dropout, his parents, or at least his mother, continued to believe in him. And I thought that was a great part of this story. And I certainly needed that when I was young. Nobody could understand his mathematics. So imagine being utterly infatuated with some subject and not having anyone to share it with. How terrible would that be? It takes a strong person with self-confidence to continue working under those circumstances. So as I said, I can't resist to show you some film clips. So the first film clip I want to show you was one of the hardest scenes that we had to assemble. Because early on, we have to explain to the audience that Ramanujan is desperate for a friend. He's desperate to have someone to share his ideas with. We also had to introduce a character. We had to introduce Ramanujan's wife, who he married when she was 9. So you can tell we lied. Devika, who plays Ramanujan's wife, was certainly not 9. And the challenge that the director asked of me was, you guys talk about mathematics being beautiful all the time. What's with that? Help us early on try to explain that it's okay for someone to be infatuated with numbers, and try to get across the idea that it's something that people could find beautiful without actually having to write down any equations. So let me show you what we did. Lights?
Go ahead. You can look. Please.
What does it all do?
It's like a painting, I think. Only imagine it is with colors you cannot see.
What good is that?
Not much for you, I'm afraid. But for me, it is everything. Maybe there is someone else who can see and understand it as well. And for them, it will be important.
Have you met them?
No, not yet.
I want to understand more than just colors I can't see.
What do you see?
Sand?
Yes? Imagine if we could look so closely that we could see each grain, each particle. You see, there are patterns in everything. The color in light, the reflections on water. In maths, these patterns reveal themselves in the most incredible form.
Lights. So that's one scene. Okay. So that was Devika. She's actually premiering a film called Swords and Scepters later this week at the Vancouver Film Festival. I encourage you to see that, certainly if you're interested in some classical Indian history, stuff that I don't really know. So in any event, as I've now told you, Ramanujan was filling his notebooks with formulas. He couldn't share his ideas with anyone, and this couldn't go on forever. And so he reached out for help. He began to write letters to the most distinguished mathematicians of the time, which were professors at Cambridge and Oxford. And he ended up writing one to a professor by the name of G.H. Hardy. Hardy is a name I think most of you know, or at least once knew, whether or not you were a mathematician. If you remember your genetics class, you may have learned about something called the Hardy-Weinberg law, which, by the way, for a mathematician is just the statement that 1/2 times 1/2 is a fourth. But we like the applied nature of that. And Hardy received this letter from Ramanujan that begins with very famous but very beautiful words. By the way, if you're wondering, Ramanujan, despite the fact that that Tamil was his native language, he went to an English-speaking high school, so he was very fluent. So if you're wondering, you know, he was very. Well, these are his words. Let me read them to you. And his handwriting was actually quite beautiful, lovely too. It puts certainly puts me to shame. The letter he wrote to Hardy begins with the words, "I beg to introduce myself to you as a clerk. I've had no university education. I've not trodden through the conventional regular course, but I'm striking out a new path for myself, and the results that I get are termed by local mathematicians as startling." And the letter goes on to have pages upon pages of crazy formulas. Here is a famous photo of the real G.H. Hardy on the left. And one of the best things about all of this movie making was that we had Jeremy Irons portray Hardy. And one of the first things we asked him to do after showing him this picture was emulate that picture. And I blew up the picture so you just see his face, but there was a perfect picture like this, and it was incredible. And if you're a fan of films, and Jeremy Irons is someone that you look up to, let me say, this guy was literally amazing. It's not just the velvety voice. It's not just his ability to use his face in many different ways to express even the subtlest of emotions. He was really incredible. In fact, he was fun to have on set. He raised everything about our project. And if you want to know, at the time he was set to play Alfred the Butler in the film Batman vs. Superman. Maybe some of you saw that poor movie. And you might remember that film, Batman vs. Superman, was delayed by a couple months for some reason. It's because Jeremy wanted to play a Cambridge professor in our small film. And I thought that was like the most awesome experience. To put this in context, we filmed The Man Who Knew Infinity in England and in India the summer that Harrison Ford broke his leg at Pinewood Studios in London. So to put the context on the timing, we were there. It was crazy. What was in this letter that Ramanujan wrote? There were some things that would make you think he was crazy. All right, so hopefully that doesn't continue. In this letter, you can find the expression that 1 plus 2 plus 3, summing up all the positive integers in order, equals negative 1/12. So there's several problems with that. But it turns out that to Hardy, who was a world-class analyst, an analytic number theorist, believe it or not, you can make sense out of his equation. So if you've never seen the mathematics related to what's called the Riemann zeta function, just take my word for it. Equal sign doesn't literally mean what you want it to mean, and there is a way to make this statement precise. And Hardy would have recognized the brilliance in this expression. And so in Hardy, Ramanujan perhaps had finally found someone who understood him. What else was in this letter? The stuff in this letter that really shocked Hardy, I'd like to take a moment to teach you. So for a teaching moment, I could ask this funny question, what is the value of x? And if you hated math in math class, it might be like the first few words of like your nightmare, but let's have fun with it. What is x? I'm asking you, what is x in this expression if x happens to be this crazy number on the right? If you know about the golden ratio, you might know this connection. But if you don't know about that, it doesn't matter. All I want you to observe is that the part of this number in red is exactly the same as the whole number on the right-hand side. It's an example of a number that lives inside of itself. And because of that, if you want to solve for x, it turns out to simplify dramatically. So you get that x is a solution to x equals 1 divided by 1 plus x. And by high school algebra, you can cross-multiply, getting this quadratic equation when you bring the 1 over. And by the quadratic formula, you get two solutions. And by positivity, this crazy expression becomes a number negative 1 plus the square root of 5 over 2. It's a trick. The number lives inside itself. If it's sufficiently complicated, it doesn't matter how complicated it is. Just declare the number to be a symbol, and you get an equation. This is the kind of thing that we do in mathematics all the time. But another thing that we do in mathematics is ask questions like this. When someone offers you a beautiful expression or a beautiful formula, a mathematician is going to ask, is that a one-off? Is that just a curiosity, or is it a glimpse of a theory? That's a very easy question to ask. It's a very hard question to answer if the answer is that it is a glimpse of a theory. So the question I just asked could be rephrased as follows. Define this function, this infinite fraction called r of q, which is 1 divided by 1 plus, and it descends forever. And the variable q appears as increasing powers of q in the numerator. And when I say that mathematicians are in the business of building theories from examples, what I want you to remember is if you let q equals 1, we're back in the realm of my trick. If we let q equals 1, it was my trick. The problem is, if q is a number other than 1, that trick no longer works. So is there a theory or not? So if you were a working scientist, one of the first things you might do is, well, let's plug in spot values for Q, like maybe -1 or a half or a quarter. Maybe we can get our hands dirty and see glimpses of a theory because we can manipulate numbers. I invite you to do that, and you probably won't get very far. Okay? So at the time when Hardy received this letter, the question would have been, can anyone on the planet evaluate R of Q for other values of Q? And the answer would have been no. And you know what Ramanujan ended his letter to Hardy with? He knew he could shock a world-class mathematician by saying, by the way, that function, let's plug in for Q e to the minus pi root n. I want you to pause and think about that for a moment. What is the nastiest number you know? It might be called pi. What is the next nastiest number you might know? It's called e. Could be e. If we have to denote a number by a letter, in particular a Greek letter or e, it's probably pretty nasty. It means we don't want to write it down. So Ramanujan said, instead of plugging in 1 or -1, let's come up with the nastiest numbers in the universe. Let's raise e to the minus pi root n power. And he said, and I took this high resolution scan of the letter and cropped it. The last 3 entries in his letter are, by the way, that. So if you let n be 1, if you let n be 4, you get equation 5. And it evaluates to something that looks not very different from what I showed you in the trick. And if you let these other parameters be chosen, he claims that these numbers all look like simple things that you could derive from the numbers I could produce from you from the trick. And that takes genius. Most people will try to plug in a half, thinking that's hard. 1/7, right? I never liked the number 1/7, and right? 1/4, I know, 0.25, 1/7, I have to stop and think about it. Forget that. He goes to e to the pi minus pi root n, and for Ramanujan, that was somehow natural. And not only was it natural, his evaluations involved numbers that we had actually already known. Where does that come from? All right. So in this film, we had very little time to explain any of what I just did to you, and maybe I didn't do a good job anyway. By the way, that last line, Ramanujan's claim, was not confirmed until about 10 years ago, and it took a full professor at Stanford to figure that out. Remember, Ramanujan died at 32. It took Brian Conrad, a very distinguished professor at Stanford, student of Andrew Wiles, a name you might know, to finally nail down what Ramanujan knew in the first letter he wrote to Hardy. In any event, in this film, we need to make it very clear that Hardy was utterly shocked by a letter from an Indian clerk. So let me show you this scene, which I happen to be in.
You know, Littlewood, this year alone, I've received correspondence from those who profess to prove the prophetic wisdom of the pyramids, the revelations of the elders of Zion, and the cryptograms which Bacon supposedly buried within the plays of the so-called Shakespeare. But a letter from an ill-educated Indian clerk in Madras challenging assertions I made in the track series really takes the biscuit.
Well, I have to say, I've made similar assertions myself.
So you admit it?
But this was 3 years ago.
No, I'm talking about the letter. Bloody brilliant, I thought. I don't know where you got the postmark. Almost had me fooled.
I simply don't know what you're talking about.
Oh, come on. I'm not a complete idiot.
I don't know how to get this into your thick skull, but whatever it is you're talking about, I'm simply not involved. Play.
Sir, you've missed Hall.
Not hungry. I tell you, there is a war coming, no doubt about it. Because we are being led like mindless, spineless sheep And no one bothers to question any of it. It's coming all right. You can smell it.
You're as paranoid as Hardy.
With all due respect, Bertie, you couldn't hold a candle. Littlewood, could I have a word?
Yes, of course. Integrals, infinite series, God knows what else. Oh, excuse me. I always forget you don't believe in a supreme being.
All right.
This chap turns out to be genuine, you might have to reconsider.
Oh, he must be genuine. Who'd have the imagination to invent all that?
Well, I'm rather flattered you thought I did. These two infinite series are the more intriguing.
Yeah, they defeated me completely. I've never seen anything like them.
Well, it's deceptive. I'll wager the hypergeometric series.
A great Littlewood stumped. He's Hobbes class, I'd say. Being inexperienced, I would very highly value any advice you give me. Yours truly, S. Ramanujan.
What does the S stand for?
You can ask him yourself.
You intend to invite him here?
Oh, no. Much better let him rot away in his office in Madras.
All right. Do you see what I mean about the facial expressions? It's really quite extraordinary. I couldn't help but say that I was in the last scene. The tennis balls that bounce into the court, yeah, that's, you know. They tried very hard to get me a cameo role, and we filmed a few scenes, but there just weren't many Japanese people in Cambridge at the time. So I made the cutting room floor on a couple occasions. So you learned a lot. Put things into perspective. This was 1913, at a time when India was part of the great English empire. How great was it? It was awful to be Indian. India was basically a colony. The Indians were subjugated as part of this colony. What you also learn here is that Hardy was so surprised by this letter from an Indian that he couldn't believe that it was even genuine. He thought it was a hoax perpetrated by his good friend John Littlewood. And by the way, you were also introduced to Bertrand Russell, it was fascinating, the circle of people that were at Trinity College at the time in Cambridge. Here you learn for the first time that Hardy was a distinguished English professor who happened to be an atheist. In fact, he's quite well known for having a feud with God. So if you know anything about Hardy and you know his readings, he had a feud with God. Talk about ego. God will not let me die because, so it was very interesting. And I told you that Ramanujan was an Indian who said his ideas came to him as visions from a goddess. For many people who saw our film, the message was, how do people from very different cultures, from very different stations in the world, social structure-wise, ever get together to A, understand each other, and B, produce something great that they would have neither of them would have been able to do alone. So for many people, that was the story. And it was actually a very interesting story. Hardy never really had many friends. He was a gay man. Ramanujan had no friends who understood his math. And in a way, they were perfect for each other, although at the same time, they could not be more different as people. And I thought that was a lovely thing. So as you heard, Hardy invited Ramanujan to Cambridge. And this scene that I'm going to show you is their first meeting in Hardy's office.
Ramanujan, we decided that for the good of everybody, you should attend some lectures.
But I'm here to publish.
Yes, all in good time, I hope. But first we need proofs of your work.
It's really nothing to worry about. It's simply a question acquainting you with the more formal methods that will benefit our future work together.
I mean, we need a common language. You wouldn't expect us to converse with you in Tamil.
No, but you expect me to speak English.
Quite. So, there'll be plenty of time for publishing.
I'm sorry, but with all humility, how does anyone know that? I don't want this to die with me.
I assure you it won't.
Thank you, sir. But I have much more to share with you. As I told you, the letter only contained a small sampling of my discoveries. You'll see I have even found a function which exactly represents the number of prime numbers less than x in the form of an infinite series.
Exactly.
Yes, I thought if we were going to publish, it should be something groundbreaking.
This is most unexpected.
Hardy, this will take a lifetime.
Maybe two.
I'm showing you scenes that I helped write. It was one of the things I'm most proud of on this project. What I like about this is that we had to make it very clear that Hardy did not yet understand the true genius in the person he had invited from India. So that's what the notebooks are all about. But we also had to emphasize that Hardy felt superior, as he naturally would. There's a lot of implicit bias in the world, but this is not implicit bias. This was just how things were supposed to be. And then you also see the humility in Ramanujan, knowing that his situation was quite fragile. And if you do remember, World War I was about to break out. This was a very tumultuous time. I also had a little bit of fun poking some of my friends who've devoted their entire careers to studying Ramanujan's notebooks. So the line where Littlewood says, "This will take an entire lifetime," that was a little poke to my friends Bruce Burnt and George Andrews, who have devoted their entire lives to making sense out of these notebooks. And that's a true story. So what you also see here, and this is something I like to tell my students, and I wish I had told my kids, but I didn't, because I didn't yet understand it fully. You have to somehow experience things a long time and sort of remove yourself from situations to understand things. But to be a good professor, there's no single way to be a good professor. Sometimes to be a good professor, you have to recognize that in your student you have someone that you cannot mold in the image of yourself. And often these students that are clearly talented but are hard to reach, just like kids could be hard to reach, are the ones that you remember years later. And you might actually regret, I wonder what happened to so-and-so. I knew they were smart. I wish they had just come to office hours. You know, if you're a professor, I'm sure you know what I mean. And so one of the important stories for us in terms of reaching the audience members who happen to be teachers or parents or university professors is in this scene where Hardy, who thought he knew how to be a professor, finally has to come to grips with, in Ramanujan I have a genius. And I have a moral responsibility to science to do the right thing. And how do I break through so that we can really find a way to work together? So the scene I'm about to show you, I think it's the last one I'm going to show you before we start talking about a few other topics and then end to the conclusion, is that in this story, I think Ramanujan matters because he represents that being a good teacher requires flexibility on the part of the mentor. And how Hardy broke through with Ramanujan was to finally get the genius to understand that in him he had gifts that the world would need. If you're really gifted like Ramanujan, you might be writing down your formulas for your own enjoyment. It was pleasing to you to write down formulas. You might not know that the formulas you're writing down might actually matter to someone. Except in this case, I assure you, they do. I'm going to end this lecture with something that's very surprising to you. You use Ramanujan's mathematics today, all of you, probably 30 or 40 times in a way that has only been introduced in the last couple of years. I'm going to prove that to you later at the end. But in any event, this is a beautiful scene. It was actually filmed at Oxford because the library at Oxford is prettier than Trinity. But I hope, certainly for the professors and students, that you can appreciate.
How did you know that theorem?
It came to me. Mr. Hardy, I don't understand why we waste our time doing all these proofs. I have the formulas.
It's not that I can't see what you've claimed. It's that I'm not sure that you know how you got there. or indeed that your claims are correct. There are subtleties which...
But they are right, sir. I have more important new ideas.
Yes, but intuition is not enough. It has to be held accountable. And a little humility would go a long way. Why do you think they want us to fail?
Because I'm Indian.
Well, yep, there is that. But also because of what we represent. Now, Euler and Jacobi, who were they?
Mathematicians.
Just names to you. Euler was the most productive mathematician of the 18th century. Most of his work done after he was blind. Jacobi, like you, was snatched from obscurity and was almost as impressive as Euler. Now, I think you are in their class. What they had in common, what I see in you, is a love of form. It's all through your notebooks. Let me ask you something. Why do you do it, any of this?
Because I have to. I see it.
Like Euler. Form for its own sake. An art unto itself. And like all art, it reflects truth. It's the only truth I know. It's my church. And you, just as Mozart could hear an entire symphony in his head, you dance with numbers to infinity. But this dance, this art, does little to endear us to certain factions who see us as mere conjurers. So if we are going to challenge areas of mathematics that are so well trod, we cannot afford to be wrong. I need you to attend your lectures, don't offend your professors, and keep doing your proofs. Otherwise, this experiment of ours will be doomed to failure. Come with me. I want to show you something. There are many ways to be honored in life. For us, being elected a fellow is certainly one, but in my humble opinion, to leave a legacy here at the Wren after we're gone is the greatest. This library houses the epistles of St. Paul, the poems of Milton, Morgan's Bible. But in my estimation, as a man of numbers, the pièce de résistance is Newton's Principia Mathematica. Now, just as Newton represents the physical aspect of our work, your notebooks represent the abstract. It took a long time for Newton to be proved, which is why we have an obligation to prove these. And if we do, I believe that one day, these notebooks will find their place here. Now, do you understand what's at stake here? Good.
That's a beautiful scene, yeah. All right, so how does the story go? Unfortunately, the true part of the story has a little bit of glory, but it's got a lot of tragedy. Ramanujan, in his time in England, wrote 30 papers, some with Hardy. He overcame great difficulties to do this. Racism, World War I, the food. He was a vegetarian trying to live in England at a time when it would have been very difficult to be a vegetarian. But despite these hardships, he ultimately was elected Fellow of the Royal Society. That is a big honor. It's a big deal. It's part of our film. We make that very clear. He was the first Indian scientist ever to be elected Fellow of the Royal Society. It's a great honor, and he was elected at a very young age. By the way, he was elected in 1918. Last October, 2018, marked the 100th anniversary of his election. And what did the Royal Society do? My friend Venki Ramakrishnan, who is now current president of the Royal Society, the first Indian president of the Royal Society, it took to the 21st century for that to happen. He's actually won the Nobel Prize in Chemistry, despite the fact that he grew up in South India, himself overcoming incredible obstacles. He was inspired by Ramanujan as a young boy. He arranged for us to celebrate the 100th anniversary of his election in London. Now, let me remind you, if the Royal Society celebrated everyone that was famous, that was part of the Royal Society, they would have no time to the actual work of science. So really, it says something that the royal family and the Royal Society celebrated this Indian man, and it was awesome. We had tuxedos. It was like super to remember this. Unfortunately, Ramanujan returned to India because he fell ill. He would die within the year, and as I said, he died at the age of 32. Despite that fact, in his last year of life, although he didn't return to good health, he continued to do mind-blowing math. And time is limited, so I won't tell you why I got into his mathematics. It's math, so we'll skip that. But let me say the work that Ramanujan did in his last year of life is the study of black holes. And just last week at the Simons Foundation, we had our third of a series of conferences on string theory, black hole physics, and Ramanujan comes up in probably every third lecture, despite the fact nobody believed black holes existed. They were supposed to be an anomaly in certain equations. So to begin to wrap up, what do we learn from Ramanujan? We learn a lot of mathematics. People have won Fields medals for it. Every prize I've won, I have to sort of make clear that I've won largely because I finally understood something that Ramanujan gave us a glimpse of. What else do we learn from Ramanujan? Well, I said that all of you used some of his mathematics dozens of times today. This is my friend P.P. Vaidyanathan. He is a professor, he's an electrical engineering professor at Caltech. In 2016, he won the IEEE Kirchhoff Award for his work in signal processing. What is signal processing? It's like one of the most important things that we use every day. Your cell phones have to receive signals and process them so that you know how to communicate. The internet, satellites, so much of the modern world depends on signal processing. And it turns out that PP discovered that in certain frequency wavelengths, a formula of Ramanujan was what should be used to make cell phones work well. So you may have noticed, and a couple years ago, I don't care what Verizon says, your cell phone probably started to sound a whole lot clearer a couple years ago, and PP is largely responsible for that. He won a prize, and if you ask him about it, he will apologize that he just happened to be flipping through Ramanujan's notebooks because someone said, you never know, maybe there'll be a beautiful formula there, and amazingly, there was. There's something, if that isn't shocking to you, then I can't really surprise you. All right. Here I am with Ramanujan's deathbed letter. He wrote this letter to Hardy shortly before he died. And let me say, these few pages have driven a lot of my work for the last 4 or 5 years. And I just can't imagine where I would be in my scientific career if this letter had not been received. It's mind-boggling to me to think about what our state of knowledge in science would be if those notebooks had been lost. And in fact, it turns out that there is a notebook called the Lost Notebook that was scheduled to be incinerated in 1960, but a mathematician by the name of Robert Rankin said, you might want to go through that notebook carefully, this box of papers carefully, and see if there's something worth salvaging. And in fact, those notebooks are the notebooks that included the formulas that PP wrote down that you take advantage of every day. I think that's incredible. All right. So what is the idea of Ramanujan? This title of this lecture was, Why Does He Matter? He matters for science. He matters for many of the reasons that I've described. Together with my student Robert Schneider, we wrote a little piece in a Hollywood magazine describing why we want people to see the film. And here's a little paragraph. I call it the idea of Ramanujan. I think Ramanujan matters because he represents endless curiosity and untapped potential, which you all have to believe in to proceed in the sciences. Science usually advances on the work of thousands over generations, fine-tuning and extending the scope of understanding. But from time to time, creative fireballs like Ramanujan burst onto the scene, propelling human thought forward. So to close, let me tell you that I read those very words in Silicon Valley at Yuri Milner's house. Yuri Milner is one of the main funders of what's called the Breakthrough Foundation. You may know about them because Mark Zuckerberg and Jack Ma are also on this foundation, and they've been giving out million-dollar prizes to scientists. A few years ago, they started a campaign to send little spaceships out to Alpha Centauri to search for extraterrestrial life. You may have seen Stephen Hawking in one of the press conferences. We screened the film that night. People from SETI were there. And after the screening, I got up on stage with the famous rich people and some of the actors, and I read those words. And I don't know what got over me. I probably had too many glasses of wine. I'd actually had dinner with Jill Tarter, who is the first director of SETI. She was the Jodie Foster character from the film Contact. It was really cool, by the way. And I think I said something like this. You know, it's really appropriate for us to be here today because, you know, you guys are searching for evidence for extraterrestrial life. The world is a big place. Shouldn't we be searching our towns and our villages for the Ramanujans right here on Earth? And I thought that was kind of a funny way to end. But Andrew Sarrazin, you may know the name, he is the president of the Templeton World Charity Foundation, was in the audience. He came up to me immediately after, he said, I love that. What can you do with the $500,000? Let's find these people. Let's give them scholarships. Let's find them. So we do that. It's now called the Spirit of Ramanujan Global Talent Search. We've now been doing it for 3 years. And we give scholarships to people who otherwise would not be able to afford to come to the United States for a summer program. We discover people. Here are some of the people that we've discovered. Boy on the right, his name is Ishwar Kartik. At 9, he developed his own formula for pi. I thought I knew pi. This 9-year-old living in a desert outside of Qatar discovered his own formula for pi. They are out there. This boy in the middle, his name is Martin Irungu. I found him in Nairobi, Kenya, hanging around the math department. He couldn't even afford to go to college. But it turns out he knew more math than any of the professors teaching at the University of Nairobi. It was shocking. Who is this guy? And now he's studying to get a PhD at ICTP in Trieste. If you don't know ICTP, it's a famous center for theoretical physics. Let's skip college. This is a boy from Kenya that we discovered and made it possible so that, you know, he didn't have to do whatever you do if you can't. I said, I don't even want to know what he would have done otherwise. And so if you know someone out there who could use help, look us up, spiritoframanujan.com. If you know a 9-year-old who's not challenged at school, who could make use of a $5,000 grant to participate in a summer program, but they can't afford it, look us up, and maybe we can help them. And I think Ramanujan matters because of that, too. All right, thank you very much. Yes. Oh, where can I read Ramanujan's notes or his notebooks? Bruce Berndt has published 7 or 8 volumes which include commentary on his formulas. You can visit a website at the University of Cambridge where they have already scanned in all of his papers. You can even, in fact, read them in his own handwriting. So it's all freely. Amazon.com, Ramanujan's notebooks, you can buy them. They're not, the Springer publishes them, so they're not cheap. But you go to the library here, I'm sure they're there. Yeah. I was kind of alluding to this. There is no such thing really as the lost notebook. I object a little bit to it, but I know why he did it. The lost notebook that I'm referring to was the notebook that was in that box of papers that was rescued and then archived in the Trinity College Library. But it was forgotten. And on a lark in 1976, George traveled to a conference in France and decided to stop in Cambridge just to rifle through Hardy's papers. And there he found about 100 sheets of papers, which he called the lost notebook, but was really forgotten. The librarian in Cambridge lectured me the first time I got there when I said, here's a lost notebook. No, 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 here in England we take our documents very seriously, never lost. But never mind. And these 100 pages, it's actually a beautiful story. It turns out these were the 100 pages that Ramanujan scribbled his last ideas on when he was in India. And Janaki saw to it that they were forwarded to England. And that's the stuff of what's called the Mach theta functions that George ended up writing his PhD thesis on without being at all aware of those pages in the library. He didn't really discover them. He's the first person to recognize their value. These I mean, if you work in history or if you're a historian, it's part of your business to travel the world doing archival work. We are not accustomed to doing that in mathematics. So that it was lost is not quite true. That he discovered is not quite true. It was forgotten. It was very carefully recorded. The librarians at Trinity are excellent librarians. It's better to say that he was the first person to recognize the value of those papers, which is very important. Yes. Okay, several questions there. I think there's some people that we were never meant to understand. I think he was really passionate about his formulas. That was clear. Whether his ideas really came to him as visions from a goddess, who knows? But what was very clear from his work is that he had this gift for discovering formulas that he found to be beautiful. That was his hobby. And it's been the work for the rest of us over the last 100 years to figure out how to translate what he thought was beautiful into a theory that we could develop. That doesn't really answer your questions, but that's how I view it. I don't know how to answer why he felt he had to do it, but I'm so grateful that he did. I hope you do recognize that when we started to make the film, it was a small project. For Irons, it was just, he wanted to play a Cambridge professor. He played so many other roles. He'd never been a Cambridge professor. And he was like a little boy. So if you ever visit Cambridge, there's a river that circumnavigates the campus called the Cam River. And he says, we have to film a scene. I have a boat. I'll bring my own boat and we'll punt the Cam. And it was like seeing this kid come out. So, all right, we'll do it. Those scenes never made the film. But the point I wanted to make is what started out as a very small project ended up being several years of work for two people who ended up really believing in this project. Jeremy actually came to Silicon Valley with us that night when the Spirit of Ramanujan STEM Search was born. He saw that. He goes, I can't believe I've had the good fortune to be part of a film that means something. You know, all the Academy Awards and all the awards that he's won, and he's won many. He said, this actually matters. And I thought that was beautiful. And if you don't know, he is now like an honorary chancellor for the University of Bath, so his work continues. And I think that's great. I think that's really great. Okay, thank you. All right. So if anybody wants to buy a book, you're from the library, maybe you guys have to